In this video, we're going to have a look at using Wrightsoft's manual S equipment selection tools to select a piece of equipment using manufacturer's chart-based performance data. The first step, obviously, is to do a load calculation and assess the load. We can do that by going to zone information page, where I might get an estimated tonnage. Remember, this is just an estimate. It's based on about a 50% indoor relative humidity, 70% sensible, 30% latent split for your equipment. I can look at my equipment selection window to look at my estimated CFM to maybe determine about what range the CFM I might need for a piece of equipment is, as we base that on some manual S formulas. And I could use the manufacturer's table data to try to assess the data points that I'm nearest, for example, about 95, 63, with a certain indoor dry bulb, indoor wet bulb, etc. But for more information on how to estimate what equipment is going to be a likely contender for being properly sized, one might want to consult the Manual S, as there's a lot of material on that. Here we're going to show you how to use the actual Interpolator tool. And so I'm going to go to the equipment selection where I'm going to show equipment, and I'm going to go to the split AC tab. Now, once again, in order to use the interpolation tools, one has to have an actual piece of equipment selected. But there's no guarantee that the actual equipment that you select is going to fall within the manual S ranges. And so before I put in the effort of finding a particular piece of equipment, I like to put a placeholder equipment in here. I just use the generic equipment tool, and that allows me to use the full perf features without having to worry about some of the other design criteria. What we're going to do here is, after selecting that generic equipment, I also need to enter the CFM that I plan to use off of my manufacturer's performance chart. When I look at the performance chart, I see that I have three CFM targets. I could use 1350, 1050, or 986. Now, I could use the Manual S's recommended CFM value and interpolate between those two data points. But as my fan charts for my duct design aren't going to be based off of what's likely going to be based off of the manufacturer's ratings, most or a lot of designers will choose to use one of those rating options to design their system. And so I might choose to enter that 1050 number if that's going to be my targeted design criteria. It also would leave me with less data to enter in the interpolation tool. I would still have to fill in the fields, but I would have to look up a full set of fewer data points, and making it a little bit easier to use that information. So that's what I'm going to do. If I'm going to use the 1050 blower point for my interpolation, then I'm going to enter here my 1050 CFM, and that's going to carry over automatically to the design AVF up here. Now, I'm going to go to this perf tab here and select my data interpolation. So I click on the button with three dots, and at the top of my capacity interpolator page, I actually have my entering dry bulb, entering wet bulb, outdoor dry bulb, and CFM data points. So I know where I should be on my chart. Now, if I go and look at the chart, see, the purpose of interpolation is finding out if this is where my equipment performs, if it's 70 degrees indoor, 63 degrees indoor wet bulb with 95 degree outdoor design temperature at 1050 CFM, but I'm not at 70, and I'm not at 75, I'm somewhere in between, and I'm not at 63, I'm not at 67, I'm somewhere in between, and it's not 95 and it's not 85, it's somewhere in between. That's averaging a lot of different data points. And so what an interpolator does is it takes all of those data points and finds the in-between. It finds the average between them and tells me what the actual capacity is going to be at these real design conditions. Okay? So it's up to me to choose design criteria and from my charts, from my manufacturer's charts, that falls to either side of each of these data points. Now, I want to choose the two closest, right? I don't want to choose the largest data point on the chart and the smallest data point on the chart and assume this will figure it out. For the purposes of accuracy, I need to choose the two closest data points. So my outdoor dry bulb of 92.1 degrees. If I look at my manufacturer's chart, I see that I have outdoor dry bulb numbers of 65, 75, 85, 95, 105, and 115. Well, if I'm going to use 92, that's between 85 and 95. So those will be the two data points that I use. And back here on my performance interpolator, I'm going to make sure that it knows that, 85 and 95, right? Now over here, I have the same thing. Now, the entering dry bulb number, some manufacturers don't publish data that has an entering dry bulb capacity or an entering dry bulb component, right? So the indoor dry bulb number might not be something that's in your chart. This particular chart has that number, but some charts have a multiplication factor, and so you might choose to calculate for entering dry bulb. Now, if you do that, you're going to need to enter the calculation factor, which your manufacturer should provide. We do provide one, which is a common one that one of the major manufacturers uses, but you may choose, or you may find out that your manufacturer uses a different factor, which you could then change. I'm actually going to be using the the entering dry bulb information. My entering dry bulb is 76 degrees, and so that means 75 and 80 degrees. I see I've got 75 and 80 degrees is going to work as my data comparison points. My CFM, this is where I might interpolate if I was designing for something in between on the performance chart. But I'm actually going to try to use that 1050 CFM. And so I'm going to put in 1050 in both of these fields. Because you need to use identical data points on my 80 degree, it automatically populates that 1050 to both of these. Now on the entering wet bulb, if I go and look at my data chart again, you remember my entering wet bulb was a little over 63 degrees, and I have 63 and 67 as indoor wet bulbs. And so if I go back here and I put in 63 and 67, those are going to be the two data points that I use here. So now let's have a closer look at the manufacturer's data chart. Some manufacturers, when they publish the capacity information, will publish that capacity as just raw BTUs, right? It might say 32,800 BTUs. Many manufacturers, including this one, publishes their data in MBTUH, meaning instead of having 32,800 BTUs, it's 32.8 MBTUH. Also, some manufacturers, when they publish their data, will publish a total capacity and a sensible capacity, or a total capacity, sensible capacity, and latent capacity. This manufacturer publishes the total capacity and the SHR, or sensible heat ratio. That'll be the percentage of this total capacity that is sensible. So depending on how your manufacturer publishes the data, you can choose, like choosing whether or not to use the entering dry bulb or have it calculated, you can choose whether or not you're going to use BTUs, where I would enter 32,800, or whether I'll choose MBTUs, where I would type in simply 32.8. Okay. Now, since that's how my data is published with MBTUH, I'm going to use the MBTUH option here. Right. Also, I can choose to enter the sensible capacity, as many manufacturers will publish, or the sensible heat ratio, as many other manufacturers publish. Since my data comes with sensible heat ratio information, that's the one I'm going to select. Now it's simply a matter of entering the data. So I need to find those data points in my manufacturer's charts. Here I've highlighted the places where that data lies, right? So I'm looking in the 85 degree column, the 95 degree column for my outdoor dry bulb, the 63 and 67 columns for the indoor wet bulb, the 75 and 80 columns for the indoor dry bulb, and the 1050 CFM. Now there's a possibility that if I wanted to go in between these CFM ranges, that I'd be looking at a whole new data set between 1050 and 1350, let's say, and 16 more data points to be entered into the Interpolator tool. And so now, through the magic of editing, we have all of that data entered from the charts into my Interpolator tool. And as we can see, as I enter all of my data points, at the bottom of this page, the actual capacity populates, as well as the percentage of the individual loads. 106% of total, 108% of sensible, 94% of latent, etc. And the program will tell me whether or not this meets the manual S requirements. Now, since this does meet my manual S requirements, I can click OK, and then I can go and find that equipment in my equipment database to select that for my reports, as I have met the criteria. Now, if it doesn't meet the criteria, you will get the message at the bottom of the Interpolator page that this does not meet Manual S criteria, at which point you either need to potentially change your CFM range or find a new matchup that will meet the criteria. If this seems like a lot of effort, it can be, which is why we prefer to use manufacturer performance calculators and, certainly, when available, the automated Manual S features that Wrightsoft has to offer from the manufacturers that provide us their data. But once you do find one that meets that criteria, and you do populate the model numbers for that equipment, I'm free to click OK here and print my Manual S report, which I find under the Equipment option and the Equipment ACCA Manual S Compliance Report, which will tell me what these capacity ranges are, and I can use that for my submittals. This concludes our tutorial on the Manual S Equipment Interpolation tool. Thank you very much for your time, and have a good day.